All right, kiddos. We're talking about some more Vex stuff. Um, we got a Vex motor. We got a Vex, what they call bearing. These act like bearings. These also act like bearings. These are thin, like washers, which act like a bearing. The washers themselves act like a bearing as well. We have a metal in a keeper that uses a threaded insert which digs into the metal, which is better to retain whatever you're putting together. These are keepers as well, but they are used by using wedging action, for instance. So when you push it on, there's like a rubber material inside it that keeps it from coming off. But over time, if you bang something like that, eventually it'll slip off. But if you put one of these on there, and if you can see it, there's a thread. It's kind of blurry, I'm sorry. If you could see it, there is a inset screw right here that you can't see, but you can tighten it and it'll tighten down on the metal. Give you an example. Let me get the tool I need. I can take this little screwdriver, the screwdriver star, push it on here, make sure it lines up with the flat area, and tighten it down. And you can't pull it off. That's a better method than this, because this one here just pushes on, and with some strength you can literally pull it off, right? I mean, for certain circumstances, that's something that doesn't move a whole lot, and this is more of a lazy, quick way. I don't like lazy ways. To me, this is the better way, but it takes some time. Also, it's metal. And one thing you never want is metal to metal, because that metal to metal, if I can get my bearings here, get it bearings. Sorry, my bad. If you can see it here, we don't want the metal to metal to rub together. So if you got very little space, you have this little plastic bearing that you can put on there, if you can see it, and then you can put it in there, and then that keeps it from being metal to metal. All right. Most of the time, if these are actually, if you'll look inside it, remember when we talked about the plastic insert for the motors? Well, these are bearings, like inside here. It's round, so it's not a drive, it's neutral. So everything that goes through here, shafts, is what their primary purpose are for. So when you stick a shaft through here, it just allows the shaft to flow freely. But why did they put them on here is because when you're going through this metal, and if you try to run this smoothly, watch what happens. This is the Minecraft. You hear that noise? It doesn't run smooth. But if you have this on here, for instance, it can also act like a bearing. Put this on here, and then this on here, and this is bolted down, then you could get a free movement. If I get it just right, it would help give you a free movement for the bearing to rotate. I mean the shaft to rotate. So this helps keep it from rubbing into the metal right here, because this is square and this is square. And so it would cause friction, cause the motor to work harder or whatever. But a lot of times, to help us out, these bearings are used. Or you can use but the reason why this is better than using a spacer is because you should use these all the time as much as possible, because this keeps the shaft minimized in a certain location. It keeps it from moving around and wiggling. It keeps it straight and keeps it from moving. And you got two bolts, screws that go on this. You got screws that go on here and here, which bolts it down and keeps it stationary. With a spacer, you have nothing to keep it from moving. So you should use one either on the backside or whatever, and use it as much as possible. And if you got a long shaft, you need to make sure you have one on both ends of it to keep it where it's not rubbing on the metal. So that's the primary purpose of using. So you could have one on this side of it, like that, like so. I'm going to use a keeper. That'll help me demonstrate this. So, sorry, I'm trying to get 2 words in line. So what that does is the screws will be here and here. So when you put weight on this, it'll be rotating inside of here and not touching the metal and bouncing up and down, which could cause damage to the motor. These motors go inside here. I mean, the shaft goes inside here. Remember, we'll have a metal insert in here at all time. And then this sometimes get between here and here, and you don't want metal to metal, so you would sometimes either put a spacer in between there, keep it from being metal to metal to that metal insert, or you can use that with this thin one right here, or however many spacers it's going to take you to get it to get in there where you don't have metal to metal rubbing up against that metal insert, and you don't want this rubbing up against the metal right here. So as much as possible, you need to use these plastic inserts or spacers. This is to help support the shaft. That's what this does. So when you bolt it down, it supports the shaft to keep it from running up against this metal part right here. So hopefully this will help you understand, and you see how that keeper works. It doesn't let it come off, right? That plastic insert, see, it's already moved a little bit already. So if we put this on both sides without being too tight, you don't want to wedge these in to the point where it has trouble moving. All right, you want to give it just a tiny bit, maybe just this amount of space between it to give it a little bit of movement. All right. Hopefully that answers your question about the setup and the motor and the shaft. If you have any questions, come see me. That's what I'm here for. I can help you with the setup. All right. Thank you, kiddos.